Hello everyone, and welcome back to CAD Builder Training. In the next few videos, we'll focus on how we can create our standard cutout, drill, and pocket tool bits, how we can set up within our tool sets, and extract our G-codes. Now, tool bits are going to be defined in the tool library, which can be found in the cut list. So we head on over to that module, and the tool library will be found at the top left of the screen. You'll see that it has 5 submenus: Tools, Feed and Speeds, Tool Set, Tool Groups Panel, and Tool Groups Edge. These last two menus actually have to deal with the door manufacturing side of things, where you're making your tool groups to define your profiles for both the inside and the outside of the door. We'll keep door manufacturing related material for a future set of videos, as they deserve their own attention. So we'll mostly focus on tools, feeds and speeds, and tool set. Tools is where you define the tool bits. Be they in their current tool set or not, it's just whatever you have in your shop and you plan on using sometime in the future. On the left side of the screen, you have your list of tools. Selecting a bit will show you its parameters on the right and the toolpath specific settings in the rightmost side of the screen. You can then create new tool bits, copy them, delete them, or adapt existing ones for your usage, which is exactly what I'll do today. I'll take this 3/8" compression and turn it into my standard cutout tool. So first, I'll start with the name at the top. I'll leave it at 3/8" compression. You might want to change yours to something you can better identify it with. Edit shape has to do with the door manufacturing, so we'll skip that for now. Image, this is where you define what picture to use for the thumbnail of the tool. You can either use our default images that we provide within the software, or you can upload one of your own. And below this, you have the description of the toolbit, where you might want to type in information like the make and model of the toolbit in case that it breaks and you need to order a replacement. You already have all the information that you need straight within the software. Then you have the general tool properties, things like the diameter of the toolbit, which you should measure using a caliper. This will affect how the tool paths are created. So again, it needs to match exactly what that toolbit is in real life. Pass depth refers to how much material the toolbit can remove in a single pass. Let's say you have this set at 1/2 inch and you're trying to cut 3/4 inch material. That means CAD Builder will use this bit to cut out the first 1/2 inch from the top, and then it will cut the last 1/4 inch in a separate pass. Right, so essentially, maximum material to remove in a single pass. For the 3/8, I will use something like 0.8 inches so that 3/4 inch material will be removed by default in a single swipe. Extra cut depth refers to how much the spoil board is sacrificed when cutting out the panel from the rest of the material. So if you just leave the tool bit to be the exact height of the material, then what can happen is the very last layer, especially with material with thin veneers on either side like plywood, the very last layer can be punched out or go underneath the tool bit, getting you not perfect cuts. So what you can do is you can send the tool bit a little bit lower than the bottom edge of the material to ensure there's a clean cut on that other side. Now you should keep this to a minimum so that as little of your spoil board is sacrificed with each cut as possible, extending the life of your spoil board. I would generally recommend something like 0.005 or 0.006 inches. Maximum cutting depth is the useful length of the bit, which depends either by its cutting length or by the way that it's been arranged inside the collet. It's just the maximum depth at which the tool will ever plunge, be it in a single pass or multiple passes. Step over is the amount of material shared between each step when routing out some pocket of material. Now, I won't use this tool for a pocket operation, so it doesn't matter for this one, but just to go into more detail, let's say you are routing out a pocket of material. You can imagine it like cutting a lawn with a lawnmower, right? You take away the first stripe, then you turn around and you take away the next step and the next step. Between each step, you will be sharing some amount of grass to make sure that there's no thin strip of grass left over at the end of the job. And the same deals with the pocket operations in the CNC. The step over is the amount of material shared between each pass to ensure there are no strands of material left over. You should keep this at a minimum so that the cut gets executed as fast as possible, but still with some guarantee of its functionality. So I would generally recommend somewhere around 1/10 of your diameter. So we'll do 0.375 divided by 10. and then entry point. This determines where the entry point will be placed relative to the edge of the part. It can either be at the corner of the part or at the middle of said edge. It's a matter of personal preference. I generally do corner. So once you're done with the general attributes, you will see the toolpath specific settings on the right, where you enable it or disable it for different operation types, and then tell CapBuilder how it should handle those types of operations. So we'll start with the cutout operation. We want to use this for the cutout, so I will check this box on. And then I tell it how to handle it, starting with the ramp in. Ramp in refers to getting the tool bit to enter the material instead of just plunging straight out of material, to move horizontally while plunging vertically, forming a ramp if we were to view it from the side of the material. Well, we generally recommend keeping this on, especially for end mill bits, as it makes the material entrance a lot smoother. And then ramp in distance is the horizontal distance over which the ramp in is performed. I'll suggest somewhere around 1 inch to 1.5 inches. And then you have the ramp out, which is the exact opposite. How should the tool exit the material once it's done cutting out the part? You can either plunge it right out or ramp it out. And generally, by the time it cuts out the panel, all the material would have been removed. So I would just leave it off. If you are noticing some burn marks when it does try to exit the panel, exit the material, then try turning on ramp out and seeing how that works. But I will keep mine off. Then you have the cut direction. Cut direction refers to the orientation of the cut in relative to the direction of the feed. And it can either be conventional or climb. And this can change based on material that you're cutting. A climb orientation will be a lot smoother, a lot less stressful on your tool bits, as it evacuates as much heat as possible into the chips. Right, so it extends the tool bit life. So why would you use conventional instead of climb? Well, this is a matter of just experience. For most plywoods and MDFs, I found conventional to leave a better surface finish. Occasionally, I would have to cut some other materials where I would use climb, and I would get a better finish instead. So my recommendation is to keep it generally at conventional. And while you're cutting, especially when you're cutting new materials, just look at the surface finish on your finished cuts versus the scrap cuts. If the scrap cuts turn out to be better, if they're not as fuzzy, if they don't have any chip out and the finished cut does, then obviously switch direction and recreate those G-codes. Arc corners, you should leave this on. What it does is when cutting the outside edges of a part, outside corners, you can either have it just the center of the tool bit follow that contour where it makes a right angle, where it transitions from one axis, stops all the way, and then goes into the other axis, or you can actually introduce a little arcing in the tool. The end panel result stays the same, but it makes the transition from axis to axis gentler on your CNC and saves a little bit of time in the deceleration, acceleration of those different motors. So you should generally leave this on. If you are noticing that your outside corners are getting some bumps or some extra cuts out of it, it usually has to do with some precision setting within your CNC, but you may also try turning it off and then checking the results. Small parts. Small parts are going to have trouble staying still while they're being fully cut out from the material, because the pull of the vacuum, if you're operating with a vacuum table, the pull is directly proportional to the area of the small part. And there are various ways that you can relieve this problem, one of which is introducing an onion skin operation, where it leaves a final layer at the bottom of the material, which then gets cut out in its own final pass. This then reduces the amount of stress when that final pass is fully cut out, reduces the likelihood of the part shifting or rotating. And you have three options here. If you leave it at none, then no parts get onion skin, they all get cut out in a single pass, or as few passes as possible based on your pass depth. If you leave it at full sheet skin, then all the parts get onion skin. If you select onion skin, then only the small parts get onion skin, whereas normal parts get cut in as few passes as possible. Once you define either onion skin or full sheet skin, you tell CapBuilder the thickness of that final onion layer. I would generally recommend somewhere around 0.06, 0.07 inches. Although again, this is a very dependent on your setup, so you might experiment with thinner or thicker thicknesses. And then you need to tell Cap Builder which parts are to be considered small and which should be normal and not get that treatment. And to this goal, you have these two parameters here: small part area in square inch and small part minimum dimension. If a piece fails either of these two thresholds, then it gets considered to be small part and therefore gets onion skinned. And the logic behind this is, let's say you have a square piece about, I don't know, 7 by 7 inches. That'd be 49 square inches. If you want something like that to be considered small and get onion skinned, then you can set this to 50 and it'll do exactly that. Now, what if you have a small part, what if you have a piece that's 7 inches but by, I don't know, 60 or 70, right? A very long, narrow piece. That will for sure clear the square inch threshold, but you can use the small part minimum dimension threshold to then catch that use case. When you get long, narrow pieces and you try to cut them out, at the ends of those narrow pieces, that's where the rotational force is maximized and they're still more likely to move than normal pieces. So I would recommend the small part minimum dimension to be somewhere around 7 or 6 inches. We'll keep it at 7. Now, this is also, again, very dependent on your setup, very dependent on your vacuum pull, dependent if you're using some extra sheet to focus the pull of the vacuum to increase the strength. So you might want to increase the threshold of this. If everything's working out, increase the threshold of the small parts and see if there's any movement there, because the fewer parts get onion skin, then the less time your cutouts are going to take. If you are noticing, however, even smaller parts getting moved that don't get onion skin, then maybe lower the threshold and make more parts get onion skin, and again, see the result of that. Feed rate reduction refers to the reduction in the feed rate for that final onion skin pass. Again, further reducing the rotational forces acting onto that tool bit. Can be 0%, 5%, 10%, but that's what it affects. Then you have the cutout onion skin manually parameter. If you check this on, it means that the CNC won't take out that final onion skin layer. It will leave it up to you to then take the part out and maybe sand the back of it to separate it from the rest of the material, or use some X-Acto knife to cut it out, which might be useful when you have a lot of parts that are very small in size and therefore the onion skin wouldn't help keeping them together anyways, or when you have some special CNC where you have to cut it out manually. Generally though, for most CNCs, I would say check this box off so that the CNC will cut out everything and fully separate the part from the material. And then you have other toolpath types below, and I will disable the 3/8" compression for everything else. I will not be using for drill, for data or pocket operations, or for any of these more specialized tool sets below. We'll take a look at how to set up a drill bit and how to set up a data tool in the upcoming videos. Tracing, sharp corner, and door toolpaths, these have to do with the door manufacturing side of things. We'll get to that in separate videos. Same goes for the half-blind dovetail and peanut joint operations. Again, we'll cover those in their own separate videos. So I'll see you next time. We'll cover how to make a drill bit and a dado tool. Thank you, and I'll see you then.